Today I am explaining about the instrumental methods of analysis. In instrumental methods of analysis, there are different types of instruments which is useful for the qualitative and quantitative estimation of pharmaceutical preparations. In that UV spectroscopy, mass spectroscopy, infrared spectroscopy comes under spectroscopic studies, and chromatographic studies like HPLC, GC and column chromatography, paper and thin layer chromatography, and some hyphenated systems are also there like LCMS and GCMS. So today I am explaining about the ultraviolet spectroscopy, which is very important for the qualitative and quantitative estimation of the pharmaceutical preparations. So what is spectroscopy first? So spectroscopy is nothing but it's a study of interaction of electromagnetic radiations with the matters such as solid, liquid and gases. So maybe these matters are in the form of pharmaceutical preparations and related substances. So electromagnetic radiations, when it is collided with the matters like solid, liquid and gases, they are interacted with the electromagnetic radiations, and these electromagnetic radiations having some properties like waves. So these electromagnetic radiations will give some wavelength. In UV region there is a 200 to 400, and in visible there is a 400 to 800 nanometers. Mostly colorless solutions will be absorbed in UV radiations, and colored solutions will be absorbed in visible radiations. So UV visible spectroscopy. So UV visible spectroscopy is basically principle is that when a electromagnetic radiations will pass on a matter, so it will absorb the light. So some lights are absorbed and some lights are transmitted. So by calculating the transmitted light, we can easily estimate the absorbed light. So when light passes through the substances, light is absorbed and some light is transmitted. So from this we can easily determine the qualitative and quantitative estimation of the pharmaceutical preparations. So due to electromagnetic radiations, they are perpendicular each other, electric as well as magnetic. So what happens, according to Einstein's equation, E is equal to hc by lambda. So when energy increases, wavelength is decreases. So when energy decreases, wavelength is also increases. So there is a electromagnetic ranges that from X-rays to microwaves. So UV visible and infrared, then mass spectroscopy, these are all basically needed for the qualitative and quantitative estimation of the pharmaceutical preparations. Particularly UV and visible are useful for quality as well as quantity estimation of pharmaceutical preparations, and infrared spectroscopy is useful for functional group determination of the pharmaceutical preparations, and mass spectroscopy is basically useful for the molecular formula and molecular masses. And NMR, nuclear magnetic resonance, is also very useful for the identification of the identification and structural elucidation of the pharmaceutical preparations and various types of related substances. So UV spectroscopy basically consisting of instruments basically consisting of sources, lens, monochromator and a sample holder as well as detectors. These sources are basically from tungsten lamp, which is very useful for visible spectroscopy, and xenon arc, mercury vapor lamp. These are all useful for UV spectroscopy. These are all the sources which can provide 200 to 800 nanometer. Basically UV spectroscopy required 200 to 400 nanometer. Mostly we are getting from mercury vapor lamp and xenon arc lamp, and the tungsten lamp is providing 400 to 800 nanometer. Then monochromator. Monochromator is a basic accessories in the UV visible spectroscopy, which is helpful for converting a polychromatic light to monochromatic light. After that, monochromatic light is falling to a sample holder which is made up of a cubate or a glass, which we can put the chemicals. So chemicals and pharmaceutical preparations. So the sample will be absorbed.